This video is meant as a tutorial on interpreting motion graphs. First off, whenever you look at a graph, you should look at the y-axis and check to see what it says. Normally it'll say position or displacement, or it might say velocity. Okay, right now we're looking at a position graph, otherwise known as a displacement graph. The slope on a graph like this indicates the velocity. The steepness of the line indicates the velocity. And velocity is how fast you're going, and also the direction. How do we know the direction that a person is moving when we look at one of these lines? The answer is, if the slope is positive, we are moving in the positive direction, and if the slope is negative, we are moving in the negative direction. And if the slope is 0, we're not moving at all. That means there's only two directions to move. We use a graph like this when we're describing something that's moving along a line, forwards and backwards along a line, or up and down, or left and right. More complicated motion would require a different graph, a different analysis. So in this section B right here, in this graph, that's a positive slope. That means a positive velocity. That means moving in the positive direction. We never have negative slope. So we never have something turning around and heading back in the direction from which it came. We never have a line angling down in this particular graph. Okay, so nothing is ever moving in the negative direction, which we often associate with left or down. Now on a position graph, any curved section indicates acceleration. So only twice during this motion was the object accelerating, and that would be at D and E. Remember, acceleration does not always mean speeding up. It just means changing your velocity over time. And there's different ways of changing your velocity. You could speed up or you could slow down. Okay? So if a curved section gets steeper, that is speeding up. In D, this little curved section is getting steeper. That's speeding up. And if the curved section gets flatter, that's slowing down. So in E, we see that the curved section is getting flatter. The slope of this little line segment, okay, is not constant. It's changing and it's getting flatter, approaching a slope of 0. That means slowing down. A horizontal line means no motion. Again, horizontal is slope of 0. That means 0 velocity, no motion. Okay? And I think the last point here is that a straight line that is not slope of 0 indicates a constant velocity. For example, at B, for that whole little segment B, the slope, the rise over run for that whole segment is the same. If you pick a little subset of B, you get the same slope as if you pick another little subset of B, same rise over run. That means you're going the same speed in the same direction for this whole little time. Okay, that's a constant velocity. And that's the only time on this graph where we have a constant velocity that is not 0. I can draw another graph here. For this first segment, we have a constant negative velocity. That means constant speed in the negative direction, which is usually left or down. Then a little horizontal segment. So after some period of time, this object is standing still. And now the object starts to move again in the positive direction. Okay, and we see this little segment is getting steeper. So the object, after being at rest for a while, is now accelerating by speeding up in the positive direction. Let's look at a couple more examples. This is a position time graph, of course. If a curved section gets flatter, that's slowing down. Here's a couple ways of doing it. That's flatter. So is that. So is that. And so is that. Those are all slowing down. These are speeding up. That's speeding up. This is speeding up, going the other way. Okay. I guess this would be speeding up as well. That's getting steeper. We start out kind of flat and we get steeper. Position is not changing very rapidly, and then it starts to change rapidly. So we're speeding up. Okay, and likewise down here. That is speeding up. Let's look at velocity graphs now. On a velocity graph, the y value indicates the velocity. Okay? I don't look at the slope of this graph to find how fast I'm going. I just look at the y value. So if this is where I am right now, how fast am I going? I just come over to the y-axis and look and read off the value. That's how fast I'm going. I'm not looking at the slope. That's because this is a velocity graph. Okay? When am I heading in the positive direction? Anytime I am up above the x-axis, which technically is the t-axis. Okay? For any line that falls in this region of the graph, that would indicate a positive velocity because the y values are all positive. When am I moving in the negative direction? Left or down? And that is whenever the graph is down here. Okay? So what about a ball that you throw straight up into the air and that comes back down? What would its velocity graph look like? As the ball is heading up, it has a positive velocity. At the very top of its motion, it has 0 velocity. And then as it comes back down, it has negative velocity. So we need to be in the positive territory, hit the 0 in the middle, and then enter the negative territory. And the graph would look like this. We start with a positive large velocity. You throw the ball up at, say, 20 meters per second. As the ball moves up, it decreases in speed. It approaches 0. And then as the ball comes down, it turns to negative velocity. The negative indicates down. And it starts with a small negative velocity and speeds up, and eventually reaches a large negative velocity, a large speed in the negative direction. What does a horizontal line mean on a velocity graph? It does not mean standing still. It means traveling at a constant velocity. Here is someone traveling in the positive direction at a constant speed. This would be someone traveling in the negative direction at a constant speed. They are not standing still. The slope of this graph actually does mean something, okay? Just like the slope on a position graph means something. The slope of this line means acceleration. Acceleration is the rate at which your velocity is changing. We see that velocity is changing. It goes from large positive to 0 to large negative. The fact that velocity is changing means we have an acceleration. you would calculate the slope, rise over run, to find the numerical value of the acceleration. And we see here that the acceleration will be negative because it's a negative slope. This has no slope, slope of 0, therefore this object is not accelerating. We know that because it's traveling at a constant velocity. If the slope angles toward the x-axis, that is slowing down. This portion of this graph, the ball is slowing down. That's when the ball is heading up, and then it reaches its peak. Moving away from the x-axis means speeding up. Here the ball is speeding up, moving away from the x-axis, which indicates 0 velocity. So this is slowing down, and so is this. Both of those are slowing down. This is slowing down, moving in the negative direction. This is slowing down, moving in the positive direction. This is speeding up in the positive direction. You can probably guess. That is speeding up in the negative direction. I think that's it for now. I do have a couple more things to show you. These bullet points right here. Something to remember. In general, if the velocity and acceleration had the same sign, if they're both positive or both negative, you will find the object speeding up. If they have opposite signs, you will find the object slowing down. I will show an example of that. Right here. We already said that's slowing down because we're heading towards 0 velocity. Okay? We have a positive velocity because we're above the x-axis, and we have a negative slope indicating a negative acceleration. Opposite signs means slowing down. Here, velocity is positive, and so is the acceleration. The acceleration is equal to the slope, which is positive. So, like signs means speeding up. That's it for now.